All right, hello, my name is Durbin. I work for Rivos. I've been contributing to RISC-V International, both, I guess, officially and unofficially, for about a year and a half now. In this talk, I'm going to build upon some of the things that Mark Kimmelstein and Kirsta touched upon in the previous two talks, and hopefully it'll shed a little more light on kind of our approach with RISC-V and how we go and build out an ecosystem for application processor systems. All right, so first a little bit of background. The A in OSA is for RV64 application processors. So Kirsta talked about the RVA profiles. That is a significant component into this part of the RISC-V ecosystem. And in addition, this is largely about targeting running rich OS stacks on top of these systems. The specification itself is for both operating system vendors as well as RISC-V system vendors. So together they need to mutually target the specification, and we'll get into how that actually pans out. And for the purpose of this and our approach, expectation-wise, is that we fully expect clients, desktop servers, could be other things as well, that would be running rich OSs will be readily available for customers and users in the future, and we need to prepare and plan for that inevitability going forward. All right, so this kind of is somewhat, in my mind, is a desire. Some of the people I've worked with in my past have probably seen similar pictures before. I always love the many-to-many lines on the top and bottom. And we're at the top here, what we have what's supposed to be representative is essentially a lot of different operating systems right at the top. And then below, different types of RISC-V systems. So we have, like I noted, like a client, like a clamshell, potentially a desktop, or servers for that matter, could be anything. But the ideal is to be able to take those off-the-shelf operating systems and target and run them on any of these types of systems. And that's really important because if we look to other ecosystems, they have this ability now, and it's extremely important. And I think for many people, which we talked about a little bit at Member Day yesterday, for people that go and build software, that low-level software and operating systems to get things to boot on different systems, how complicated that is. And so to an end user, that is usually underappreciated how much work that goes into that. So by taking the OSA-SE specification, which we'll get into, that we should be able to target this type of ecosystem and mimic what has happened in other competing ecosystems. All right, so definition-wise, at the top we have the operating system. Below is the OSA-SEE. SEE stands, as previously noted, Supervisor Execution Environment. And in the middle stands in the Supervisor Execution Environment interface. And that is how the operating system will say, or kernel, interacts, or bootloader for that matter, interacts with the SEE proper. All right, so the name of the spec, so side tangent, there's a bike shedding moment in all of this. The name of the spec currently is OSA-SEE. One could argue maybe it should be OSA-SEI. That said, we can always talk about that later. But the important part here is the caller, callee, and or the user/provider relationship. So the operating system, which is comprised of usually a bootloader as well as a kernel, uses the SEI to talk to the SEE. And the SEE provider could be firmware, or Kirsta noted earlier, could be a hypervisor for that matter, provides those sorts of services and things upwards so that can use it. And that interface, as we'll get into what is comprised in there, it could be both sort of calls for them, or it could be more interrogation of data structures to understand things about the system itself. So, as noted, boot and runtime components are involved in all of this. So, for bootloaders, we need to assist them to be able to load and then jump into the kernel and then the operating system can run. And then we have a runtime component. So that we can, we'll say load device drivers, that sort of thing. And a lot of what we're talking about is like tables and other things to convey information about the system into the operating system itself. and also provide essential services such as power management or heart state management, that sort of thing. How do we do this? Well, it's not really that large of a surprise. Industry standards. It's not like we're paving our new way. And many of the industry standards that are used are listed here. UEFI is obviously integral in the ecosystem at large, in the computing ecosystem, to manage and run operating system and load operating systems, save integral variables, interface against the boot medium, how you choose the boot priority of a particular, if you have many kernels loaded or operating systems on the system itself. Device tree is more of a data structure in memory that the kernels can use to obtain information about the system. So again, this is more about capabilities of hearts or devices in the system to load drivers. ACPI likewise provides similar capabilities as device tree, but it also has a runtime component, and some of the system providers like to use ACPI because it does have a runtime component to allow system-specific things to happen and support to take place. And in addition to that, we've got the RISC-V SBI specification, and that lists a lot of the e-calls from the kernel to the SEE to what's in there right now is like heart state management, that sort of thing. Again, could be also system-specific support or system-specific SBI calls. Lastly, there's an SMBIOS component that some OEMs like to utilize to convey information for larger machine management. And lastly, like we have a platform and runtime services TG that is driving a lot of these changes to the specifications. There's a lot of activity going on as we're figuring out all the things that are necessary for booting RISC-V systems and things like that. That's not to say that no RISC-V system can boot now. It obviously can. But as we're looking at the broader landscape, there are missing pieces. And one of the bigger ones is ACPI support and getting all that support in place there. All right, so current and future hardware support. So as Kirsten noted, there's a sequence of profiles that are forthcoming, and hardware will intercept those. And in the TG itself, in the past few months, it's been voiced it's important to support a lot of these things. That doesn't mean that there will be a potential off-the-shelf operating system targeting every single profile. That's not really up to us, but we're trying to provide the foundation to do that. But we do believe it is important to support all these different types of systems and their market needs. And so to that effect, what we end up seeing is that there are some people who build systems that really want to align to ACPI. A lot of people want to align to device tree. That needs to be optional in the spec, and that's how that becomes a necessity. And so we're still talking about how we manage some of that optionality within the spec going forward, but there's not one size fits all. And if we think back to the previous slides where we were talking about different systems and things that are supported, what we believe from an OSA SEE spec standpoint is that we think there's a large number of overlap that we can leverage across the board, across the forthcoming systems. So that's where some of this optionality is coming into play. That said, it's kind of up to the market on both operating system vendors and system providers on how that's going to become realized. But again, with the profiles, it allows a lot more ease to target something that could be run on many, many different systems that's the same binary. All right, so Kirsten talked about this about platforms, and I do think this is an extremely important point. There's a lot of interest within RVI and members to take a lot of these pieces to, we'll say, put a box around it for that matter, and specify more of the system level in addition to the profile. So as Kirsten noted, profiles are providing ISA information. The OSA SE is providing a way that you can have more off-the-shelf standard binary distributions running on these systems, but there is still, we'll say, chatter, for lack of a better term, of people wanting more definition around system architecture. And that's what that we were talking about will most likely be coming in 2023 in that pursuit. But what does that mean then in practice? So in here at the bottom we say I have potentially many profiles. Well, that's a platform. But in this case, and it's an instantiation, if these boxes are all representing binary distributions, what you really end up seeing is that there could be a whole portfolio of solutions. So it could be lots of different operating system distributions, for example, like RV8, that's targeting RV820, RV823, such and such. We'll see how this becomes realized, but this is what can be done. That doesn't mean we're making this a requirement across the board, because it is fundamentally up to the providers themselves to decide. So we've been talking in the TG itself about different aspects of this, and then starting in this coming year, we're going to be really focused on hammering out the layout of the spec and how we provide the optionality and that sort of thing like that. But ultimately, we believe we'll be able to enable a thriving ecosystem of RISC-V systems. And then, obviously, if people that have been involved in many of the OEMs, ODM interaction type of thing, we believe that this can definitely be leveraged. It's nothing. It's not rocket science. It's nothing new, but it is. We need to figure out how to target it specifically for the RISC-V ecosystem, because the RISC-V ecosystem is unique, and because it includes a lot of members, a lot of different interests, and as Christian noted, there is that variability, but we're also providing these pieces so that we can have some consistency as well. And then ultimately, when you hit alignment across these types of things, a particular profile and everything else, we will get the ability to have binary compatibility across the systems. All right, this is the resources. We welcome people to participate. This is all for I uploaded the slides so people can click links. Obviously, you don't have to copy them down now. So anyway, Q&A.
Yeah.
I have a seated question, so if no one has one, I'm happy to.
I have a microphone. Anybody in the audience have a question? Hey, look at this.
Wow.
Did you give these guys questions to ask?
I did not.
Thank you. Good afternoon, and I can confirm I have not been pre-primed with a question. A comment and a question, I guess. My comment would be, there's no such thing as an off-the-shelf operating system. If your operating system is running, it's because there's a group of people that lovingly crafted that and built it in order to run. So the question now comes down to, will there be a set of test suites that will be available to the operating system vendors? Otherwise, we spend a lot of time debugging hardware.
Yeah, so I forgot to mention that. Yes, we have been talking about having a test suite to ensure conformance. Again, we think we can look at previous solutions that help us craft that, and I think we have a good framework to do that. So that will definitely be necessary, or to make it easier, obviously, so that we can say, hey, this system will run, right, given these constraints. Sorry, I was hearing feedback.
There'll be a place where those, thank you, there'll be a public place where the results of those test suites will be available.
Oh, yeah, I actually haven't thought of that, and it hasn't been brought up, but that's a very good point, to basically have a registry of systems that are compliant at that point, right? That is helpful.
Okay, thank you.
Mm-hmm.
Next question. I swear I saw two hands. Maybe it was the same question, two people.
Maybe. I know lunch is after this, so I'm sure people are hungry. But
yeah, that's true.
So my seated question was, in what we're constructing within RISC-V, how does that compare to how ARM sets their stuff up? And that's kind of interesting in that you have the BSA in ARM, which is the base system architecture, and those requirements include both ISA type things, which is analogous to what we have in the RISC-V profile side of things. But in addition to, in that spec is also the system level architecture pieces like, SMMUs and things like that, DMA, memory, what type of memory, that sort of thing. And that was where we were alluding to for 2023 in how we want to build out platforms that further do that. And the BBRs, which is the base boot requirements in an ARM world, basically depend on the BSA. So in this case, the profile for RISC-V the platform in RISC-V will be able to take an ISA a RISC-V profile, OSA SEE, and then in addition to that, and that will be the equivalent of how ARM is constructing their systems and composing their requirements. And so that's how, if anyone was interested or thinking about that, that's how I view it. I don't know. That's how I think that we can make something equivalent as well.
So another question. Sorry, I seem to be dominating this. Will you consider having minimum hardware specifications that go along with this? So, for instance, if you need to have virtualization support, you're probably going to need an IOMMU.
Correct.
That goes with that.
So that I think is where we'll bring in the platform side of things, that the members that are interested in having some commonality, we'll say from a specification standpoint, like we think this is extremely important for a server platform, we'll say, and list those types of things. So if you're going to have virtualization, you need IOMMU and whatnot. And that is where those sorts of requirements will reside. But in the larger composition, we can take all those pieces, and then you could potentially have operating systems that target a server, for example, platform. Or you could have a more generic, we'll say like OSA sort of thing, which is maybe just the bare minimum, right? But you can have both worlds.
And would you see the standard fragmenting down to layers of hardware like IOMMUs? I mean, how many IOMMUs do you perceive there'll be in the overall ecosystem, each coming with its own firmware set? So
sorry, I didn't entirely understand the question. Were you saying like the number of IOMMU implementations or the number of IOMMUs in a system?
Implementations in terms of firmware.
And you're wondering how we would deal with the numbers? Yeah. Okay, so obviously, we are working on the IOMMU specification. I think Ved has a talk later today that talks about that. And yes, that allows an IP vendor to, anyone could build an IOMMU as long as it meets the specification. How do I think that's going to play out in practice? The numbers and types, I think we'll see. But my guess is the initial go, there will be a number of different implementations. They'll probably have certain quirks in the drivers that may not all be conformant, but I think overall at large that there will be convergence. I do not foresee, and this is just my opinion, but like there be a limitation of you can only have one IOMMU vendor in a system or something like that. That doesn't really make a lot of sense, but to me at least. I don't know if that was your question. I apologize if it wasn't.
Yeah, that was my question.
Okay.
I'd also say, do you see a standardization inside of each of the profiles in terms of size of MMU pages? So 4K, 16K, 64K?
Yeah, I think what we'll see and how that falls out, and it will probably parallel the profile, right? It's not really helpful if the heart MMU has support for certain page sizes, and then you have an IOMMU that doesn't support the same page sizes. So
yes.
When you're pairing and building a system or designing a system, you obviously want to match that. And so if we are going to mandate some of the page sizes in a profile, then likewise, when you build out a platform, you would want to have a similar mandatory page size on all IOMMUs that would be in the system then.
Let me give you an example. Say you have a hypervisor that's running an operating system with a larger page size than the hypervisor was configured for. There's all kinds of interesting undocumented features that can come along with that.
Sure. I think we'll have to go through all those details to figure that out. I don't know how some of these requirements will actually play out in practice, like to be exhaustive of every potential combination. Obviously, we need to be thinking about those types of things because there are ramifications to that, but I think in general, we're trying to construct a lot of these sort of specifications to enable growth on top of it from an iterative standpoint as opposed to trying to solve every potential problem up front. But obviously, as things come in front of us, like while we're specifying stuff, I would imagine that we can say, hey, this is really important to not allow this or to think about the situation and that sort of thing.
Sure. Thank you.
Being conscious of lunch, I'm going to say we have time for one more question. No pressure, but it might need to be a great one, Drew.
Uh-oh.
Just kidding. Let me check online. Nothing online. So, Drew, you are the last question.
I'm just trying to, in my head, differentiate between the PRS and the OSA SEE group. Could you just go over that a little bit about what would fall in one or the other?
Yeah, so I would say that's more of like how we're doing like TGs and RVI necessarily. Like we obviously work very closely with one another. The charter for the platform runtime services TG is largely to drive spec changes, but those don't just like come out of that particular group. Like for example, a lot of the changes that they're driving right now even are like updates to the RISC-V SPI spec for like hypervisor stuff, which is obviously somewhat related to OSs, but not exactly like, so the reason I give that example is that as we have these discussions in different forums, what ends up happening is from a TG standpoint, the PRS TG is supposed to drive those. So these other groups will say, hey, we think we need another SPI extension here. ACPI spec needs to be updated there. UEFI spec needs to be updated there. And we come together and talk about those, and then we drive through either if it's an industry standard or within a RISC-V controlled spec type of a thing. So there's no real magic to the delineation. It's just how we've chartered the groups, basically.
All right, everybody, let's give Aaron a round of applause to thank him for his time.
Thank you.